Okay, we are ready for section 3.4. And there's two topics in this. We're going to talk about two different types of equations and how to solve them. The first one is rational equations, which we're going to define in just a moment. And then the second is radical equations, which are, as the name suggests, equations that have radicals. The word radical means like square root, sine, cubed roots, all of those roots. So that's going to be the second half of this section. I'm going to do that in a second video. So this one we're just going to talk about rational equations. Okay, so we're going to start by just defining what a rational equation is. It's a fraction. Actually, this is a rational expression. Expression is kind of like in English a phrase, whereas an equation, which we're also going to talk about rational equations, is like the sentence. So a rational expression is a fraction where either the numerator or the denominator or both are polynomials. The equations that have a rational expression in them, so again, think of equations that has the equal sign, it's like a sentence, whereas the expressions are just a phrase, like just a fraction. An equation that has a rational expression is a rational equation. Kind of makes sense, right? The first step to solve a rational equation is to eliminate the fractions. That's what I like to do. Anytime I see fractions, if I can get rid of them, it just simplifies the problem. So that's what we're going to do almost all the time whenever we see a rational equation, which means it's an equation that has a fraction in it, and the fraction has a polynomial either in the numerator or denominator. This technique also works whenever it's just regular fractions that just have numbers or variables. Okay, multiply both sides of the equation by the least common denominator. Or the LCD. And it's the least common multiple of the denominators. So let's take a step back and let's step away from the rational equations and just talk about fractions in general. If we're talking about the least common denominator, we want the smallest number that all of the denominators go into evenly, or that can be divided by the denominators. So out here to the side, let's just work with regular fractions. Let's say like we have 2/9 and 1/12. What would be the smallest number that both of those would go into evenly? So if we had an equation, it didn't have a polynomial, but it had these fractions, we could do the same technique of finding the least common denominator and multiply both sides by that to get rid of the fractions. And I think I've probably even done that in some examples already this year. So to find the smallest number, and sometimes it just pops out and you just see it right away and you don't have to dig any deeper. But if you're not sure that you know what the smallest number they both go into, break it down into the factors. 9 is 3 times 3. 12 breaks down into 4 times 3, but then 4 breaks down again, so we get 2 times 2 is 3. And then you just make sure you take the highest power of each of those factors. So in this case, we have two factors, prime factors, 2 and 3, and the least common denominator is going to take the highest power of each of those. So the 2, the highest power is squared, and 3, we have a 3 squared, and we have a 3. The highest power is 3 squared. So the least common denominator is going to be those multiplied together. 2 squared is 4, 3 squared is 9, so we get 36. And you might have figured that out. 9 and 12, numbers we work with pretty often, so that you might have been able to go through that in your head. But whenever you are, break it down into factors and then take the highest power of each of those factors, because we have to make sure that it all goes into this number we're coming up with. And here's an example of a rational equation where the polynomials are all in the numerator. There's no polynomials in the denominator. So our least common denominator is going to be numeric, like what we did over here. So we look at our two denominators. We have 4 and 5. What is the smallest number that they will both go into? Well, we could break the 4 down if you need to. It's 2 times 2. 5 doesn't have any 2, so our least common denominator has to have 2 squared, and it has to have 5. So we get 4 times 5, which is 20. So we're going to multiply both sides by 20. I sometimes just think of it as multiplying each of the fractions and each of the whole numbers by 20, and that way I don't forget to distribute. And then I also have to multiply the 15 by 20. Okay, and I'm going to erase all of here so we have some more room to work. Hopefully you got that down if you needed it. If not, all you have to do is go back in the video and it'll be there. Okay, so I'm going to rewrite this. I'm going to put the 20s over 1 so that I can treat them like a fraction. And then the 20 and the 4 reduce, leaving a 5 in the numerator. So that gives me 5 times x plus 2. And then the next 20, putting it over 1, it reduces with the 5, leaving a 4. And it's a negative 4. And then on the right side, I have 20 times 15, which is 300. So to work this out, I need to distribute 5x plus 10 minus 4x plus 4, because it's negative 4 times a negative 1, equals 300. Combine these are on the same side, so I just add them together. I get x plus 14 equals 300. Not sure why my pen gave out there. That was the 10 plus 4. Subtract 14, and I end up with x equals 286. Now always check your answer, not just to see if you made mistakes, but what you're going to find out is whenever you have variables in the denominator, sometimes you get some extra solutions. Remember, we don't want our denominator ever to be 0. In this case, in our original problem, our denominators were numbers, so we don't have to worry about that here. But from this problem on, once we start working through more of these, you always want to check just in case your answer makes the denominator 0, and then it wouldn't be a solution. So let's just double check this. 286 over 4 minus 286 minus 1 equals 15. 286 plus 2 would be 288. Divide by 4, I get 70. Let's see, 288. 72, 288, yeah, so 28 divided by 4 is 7, and then the 8 divided by 4 is 2, minus, this would be 285 when I subtract the 1, divide that by 5, I get 50, 3 left over, 57. Equals 15, and you can do the math. 72 minus 15, that does equal 15, or 72 minus 57. So our answer is 286. Okay, let's do one where we have some polynomials in the denominator. One thing that I posted in this week's lessons is some factoring review. So if factoring at all, as we go through all of the things from this week, when we get to factoring, if you have any fuzziness at all, that section is just 8 questions. It's optional. It doesn't count toward a grade, but it will definitely help you. I try to pull in one of each type of factoring, and if there's any of those that give you problems, do look at the extra help inside of my math lab, or even Google to get some extra worksheets or something on factoring. Just make sure that you're good on factoring, because it's going to keep coming up to haunt you. And if it's been a while since you've really done a lot of factoring review, you need to make sure you do that. Okay, so let's look at this one. Now remember, in order to find our least common multiple or our least common denominator up here with when our denominators were numbers, we factored, and then we made sure we included each factor. We factored 4 into 2 by 2, and then we had the 5, and so we included the 2 squared and the 5. Same thing here. If these factor, you're going to factor them, and sometimes you're going to have the same factor in more than one denominator. You don't have to include it more than once as long as it doesn't have a power. In this case, our denominator is 3x plus 2. that doesn't factor, and then 2x is just one term, so that doesn't factor. So our least common multiple is just going to be those two denominators times themselves. Because they don't factor, we're just taking the two of them times each other. Okay, so that's our least common multiple. So that means we're going to multiply each of the fractions times x plus 2. And then here's our first fraction, 5 over 3x equals 2x. And we're going to get a little bit about how you might be able to save yourself a little bit of time writing all this down. But just be careful if you try to shortcut it. But we'll talk about that a little bit. Okay, these aren't a fraction, so I'm just going to put them over 1. Just like other factors, you can reduce. Now the thing here is to make sure that when you cancel, you're canceling out things that go together, that have parentheses around them. And even though there weren't parentheses around that 3x plus 2 in the denominator, anytime you have a fraction, the denominator's in parentheses, the numerator's in parentheses. So we can't just cancel, like we can't cancel this 2 with that 2 down there, or the x's. We have to cancel in these groupings, in the factors. But the 3x plus 2 appears in parentheses. Down here it is as well, since it is the whole denominator. So those will cancel. So we're left with 10x times, all the denominators went away. And then the 2's cancel, the x's cancel over here. And we get 3 times, remember this is in parentheses, so even though this is written kind of backwards, we're going to distribute the 3 across the parentheses and get 9x plus 6. Solving it, subtract the 9x, and we get x equals 6. Now, just like we said before, we have to check our answer anytime when you have an x in the denominator. You're not checking to see if you made mistakes. You're checking to make sure the answer actually works. Even if you did it completely right, you can come up with answers that end up not being right, and those are called extraneous solutions, because they aren't really solutions, even though as you work through the problem, it indicated that they were solutions. So I'm just plugging in the 6 everywhere I see a x. In the denominator, it's just as if there's parentheses here, so I need to do multiplication, then addition. So 18 plus 2 is 20. And then over 12. 5 over 20 reduces to 1/4. 3 reduces to 1/4. So that did work out. And we have x equals 6. Now, whenever it's just like this last problem, it was a fraction equal to a fraction. There is a shortcut, and it's called cross multiplying. And this is when you have a fraction equal to another fraction. It's the only time you can do this. So be careful. You can't do this all the time, and we're going to have more examples after this that you can't do it. But we could have done it on this first one. And what you do is you just take the numerator on one side times the denominator on the other, equals, and then the denominator on one side times the numerator on the other side. And then that gives you the equation to go from there. So on this one, we're going to use cross multiplying. We're going to take 2x, numerator on the left side, times the denominator on the right. And remember, it says if there's parentheses around these denominators. And now we take the denominator on the left side times the numerator on the right side. And that saved us all this extra writing. But remember, you can only do this when you have a fraction equals to a fraction. So now we can distribute to x squared minus 6x equals 5x minus 5. And I want to get, since I have a quadratic equation, I have an x squared. Remember, to solve a quadratic, you want everything on one side equal to 0, and then you check to see if you can factor. So I'm going to subtract the 5x over and also subtract the negative 5, which is the same as adding 5. So I get 2x squared. Negative 6x, subtract the 5x over, and then add 5. And now that's left with just 0. And I want to check and see if I factor. So again, if you're rusty on factoring, do some review. First times first has to multiply to give me x squared. The only way that could work is 2x times x. And then over here on the right side, I want two numbers that multiply to give me 5. But when I do my O and my I, the outside and the inside, I end up with negative 11. So let's just play with that. Two numbers that I can multiply to give me 5 would be either 5 times 1 or negative 5 times negative 1. And I could either put the 5 here or the 5 there. So let's just try, and I can erase this. So if you're using pen, you might not want to do this. I'm just going to use negative, because I see that here in the middle I get a negative, so that gives me an indication I'm probably going to be taking negative times negative. When I do outside, I get negative 2, inside I get negative 5. So when I add those together, that would force this number would have to be negative 7, but it's not. So I know that that's not a good solution. So let me erase that. And this, instead of putting the 5 in the first spot, I'm going to put 1 and then put the 5 over here on the right. And this time I get 2 times negative 5 is negative 10, and negative 1 times x is negative 1x. So that does give me the negative 11 that I want. Now it's possible that you try all these possibilities and none of them work. And that means that then how do we solve a quadratic? Remember we had the 5 different ways that are in this chapter. Factoring was one of them, but it doesn't always work. If it doesn't work, I usually move to the quadratic formula. So that would be my next step that I would do if this hadn't factored, but it does. And so now we set minus 1 equal to 0 and x minus 5 equal to 0. Adding 1 to both sides gives me 2x equals 1. Divide by 2, I get x equals 1/2. And for the other one, x equals 5. So that's my two answers. But just like we said before, we need to check those. And I'm just going to do my check down here on the next page. I know that doesn't necessarily work for you, but I'm going to do it down here since I've run out of room. I have two answers I need to check. They might both be right, or there might be an extra one. So I'm going to start with the 1/2. 1/2 minus 1. 1/2 minus 3. So on the left side, remember you have to treat this like there's parentheses. So I have to take that 1/2 minus 1 in the denominator. In the numerator, 2 times 1/2 is 1. Just put the 2 over 1. 1/2 minus 1 is going to be negative 1/2. And 1/2 minus 3, 3 is the same as 6/2. So if I have a negative 6/2 and a positive, I'm going to have a negative 5/2. Okay. And keep working up here. 1 divided by negative 1/2 is the same as multiplying by positive or negative 2. So I get negative 2. And then here, this would be the same as multiplying by negative 2 over 5. The 5s will cancel and I get negative 2. So the 1/2 actually works. So we can circle that. That's a good answer. Let's check the 5. Plugging 5 in, I get 2 times 5 over 5 minus 1. 5 over 5 minus 3. 2 times 5 is 10. 5 minus 1 is 4. 5 over 2. And that also works. The 10 over 4 reduces to 5 over 2. So that one works as well. So we got two answers, 1/2 and 5. Okay, let's do a couple more examples and then we'll stop this video and then we'll do a second one for the second half of this section. Okay, this one is not one that we can just do cross multiplying because there are 3 fractions. There's not just a fraction equal to a fraction. So we need to find the least common denominator. And let's factor each of these denominators first. You may recognize that x squared minus 9 is x minus 3 times x plus 3. And notice our other two denominators are those two factors. So if we use x minus 3 times x plus 3, we've covered everything. Just like before, we look to make sure we have all of the factors are represented in our least common denominator. And there we have it. Okay, I'm going to write out what we're going to do and then talk about maybe next time you don't have to write it all out. We're basically going to take every single fraction times our least common denominator. So we need to take this first one times x minus 3. Take that times 2 over, and I'm going to go ahead and leave this factored, x minus 3 times x plus 3 plus, and then I need to take x minus 3 times x plus 5 over x minus 3. And then x minus 3 times x plus 3 times 3 over x plus 3. Put all of one so I remember that they're in the numerator. Whew, that's a lot of writing, isn't it? Well, the reason that we do this is to get our denominators to cancel out. In this first one, the x minus 3 cancels, so does the x plus 3. So we're left with 2. Second one, the x minus 3's cancel, so we're left with 5, and x plus 3, we'll have to distribute that. And over here, the x plus 3's cancel, and we're left with 3 times x minus 3. So, do you think we could go straight here and leave out that whole big long thing that I wrote? I think you can if you're careful. And just like any time you don't write out steps, you just have to be a little extra careful to make sure that you don't skip a step or get lost somewhere in the shuffle. So let's think about what we're doing. We're taking our least common denominator times each of these fractions. And when we look at the denominators, each time part of that is going to cancel out. So if you just remember to check what cancels and make sure that everything else you include, you don't really have to write out that big long step. So for this very first fraction, 2 over x squared minus 9, do you see how everything's going to cancel out? That denominator is exactly the same as our least common denominator. So we can just write the 2, the numerator, because the x squared minus 9 is all going to cancel out with our least common denominator. Okay, then we come to the next fraction, 5 over x minus 3. Do you see how the x minus 3's are going to cancel? So what are you left with? You're left with the x plus 3. So if you can do that in your head, that's okay. That's a lot of writing that you'll save, but just be really, really careful. It's the ones that don't cancel out. When you multiply, that x minus 3 is going to cancel out with the x minus 3 in our least common denominator, and you're going to be left with x plus 3. And the very last one, again, when we multiply by our least common denominator, the x plus 3 is going to cancel, and you're left with x minus 3, and then of course the 3 that's in the numerator. Okay, so finishing this out, this is just a bunch of algebra, so I'm going to go through. If you need to pause the video, you can. I would suggest you pause and work it on your own, and then you check that you got everything the way it should be. And then, of course, once we get our answer, just like we've talked about before, we need to check it in our original problem. So I'm going to do that right up here. And I know sometimes it's like, oh, there's messy fractions. I don't want to have to do it. But trust me, you have to do it on these. It doesn't matter how careful you are and how sure you are of your answer. You can have extraneous answers even if you did everything right. Okay, so 13 squared is 169. Minus 9 is going to be 160 plus 5 over negative 16. 3 over 10. So I do my subtraction here. Actually, to subtract these, I'm going to make them both over 160. I'm just going to make that 50 over 160 because then I can do that calculation. I know we could reduce these down to 80, but 50 is negative, positive 2, that would be negative 48 over 16 equals 3/10. And that should have been a negative 10 down here in the denominator, so this is negative as well. And yes, that will reduce. If I divide, because that was over 160. if I divide by 16, that becomes a 10, and this becomes a 3. So yes, it works. So our answer is the negative 13. Okay, I've got one more I want to show you, and then I'll switch over to the other video. I'm going to erase my check because it kind of ran into this other problem. Okay, I'm going to pause. Okay, I was able to make a little bit of room to work this last problem, but not a lot. Okay, so we need to first find the least common denominator. So just since don't have a whole lot of room here, I'm going to do it up here. We do need to factor each of the denominators if they factor. The first one does not, so it is a factor, x plus 2. We have to include x plus 2. We need to include x. And then this last one does factor, and so it's x and x plus 2, but we've already accounted for those, so we're good with just x plus 2. Now I'm going to try doing it like we did this one where we said we can skip all the writing out. So we're going to go straight to here, but just remember what we're doing behind the scenes is right up here. So I need to multiply 3x over x plus 2 times my least common denominator. The x plus 2 is going to cancel, and I'm left with just 3x times x. The x plus 2 cancels. In the next one, the x's cancel, so I have x times x plus 2. And then the last fraction, which is on the other side of the equal sign, the x cancels, so does the x plus 2, so I'm left with just the numerator of 12. So now, doing a little algebra. This is a quadratic, so I need to get everything to one side, which means subtracting the 12. But we already have 12, so 12 minus 12 is 0. And we're left with just 3x squared plus 6x equals 0. It's a binomial. We do have a greatest common factor. I can factor out a 3x. So we're going to get two answers. One comes from 3x equals 0, which is going to be x equals 0, and then x plus 2 equals 0, x equals negative 2. And let's check our answers. So plugging in 0, let's see. We're running out of room here, aren't we? Okay, you've got this last problem, right? So I can get rid of some of this. Okay, I made some room. So just to recap, we found two numbers, x equals 0 and x equals negative 2. We need to check to see if those work. First one becomes 3 times 0 over 0 plus 2 plus 6 over 0 equals 12 times 0 squared plus 2 times 0. Does anybody see a problem with this? Let's go ahead and keep working it out. If you don't see it yet, 3 times 0 is 0. That's not a big deal. 0 divided by 2, which is going to be 0. But then this next term, we get 6 divided by 0. This cannot happen. We can't divide by 0. So that means our solution of x equals 0 is an extraneous solution, and we cross it out. We wouldn't put that as an answer to this problem. Okay, let's try the 2. So same thing. Let me erase. Okay, there you go. I'm going to replace the x with 2, negative 2, I'm sorry. Negative 2 plus 2 plus 6 over negative 2. Okay, and if you already saw it, then you know that this one doesn't work either. 2 times negative 2 is negative 6, but look what happens in the denominator. Negative 2 plus 2 is 0. We don't even have to keep going because we've already found it won't work. So this problem actually has no solution. Because all of the solutions that we got when we worked it out turned out to not be good solutions. Okay, that's it for this half of the section. We'll be back for the last half.